welcome. Today we're looking at 4.4, properties of rational functions. So we're transitioning from our polynomial functions into rational functions. Hopefully rational functions is a little bit easier because it's less things to talk about. Well, it depends. But for the most part, we're looking at the rational functions as, if we're talking about r of x being a rational function, as two polynomial functions dividing each other. So p of x and q of x are polynomials and we're just dividing. So if we look at all these three different functions, these are different types of rational functions. So notice that the top and bottom are both polynomials. Even though one that's 1, remember 1 is a 0-degree polynomial because there's no x on it. So these are all definitely rational functions. And it's asking us to find domain. So domain is something that we should probably be pretty familiar with by now. We practiced it earlier. But the thing that we're looking at for domain is what would make the denominator 0. And that would be our domain restriction. So the first one is pretty easy. What minus 5 is equal to 0? Well, then that would be 5, right? So we have to say for our domain x such that x is not equal to 5. And it can't be equal to 5 again because 5 minus 5 is 0 and we can't divide by 0. Okay, another way to think about this, if you want to write it in interval notation, from negative infinity to 5 parentheses, right, because it doesn't include the point, and then 5 to infinity. Okay, if we look at the second one, it's a little bit more complex, but because we have that squared, but what we can do is we can, x squared minus 4, set it equal to 0 so we can find our domain restrictions. So for this one, we're going to add 4 both sides. X squared equals 4. And then when we square root, we got x is equal to positive and negative square root of 4, which is 2. All right, so if we're trying to write this formally, x such that x is not equal to negative 2 and 2. Or if we're doing this in interval notation, negative infinity to negative 2, negative 2 to positive 2, and then from 2 to infinity. Okay, and then the last one. So again, we can say x squared plus 1 equals 0. And then if we subtract 1, x squared equals negative 1. And then when we square root, we have a square root negative inside. So I know this is going to be imaginary already. So this one doesn't count in our domain restrictions. There are no restrictions because there's no real numbers that are going to make our denominator 0. So for this one, it would be all real numbers. And that's it. That was a short one. I didn't realize it was that short. Okay, so yeah.